In this video, I will demonstrate how to construct the pot-in-bucket float valve mechanism, as described in our paper titled A Low-Cost Method to Rapidly and Accurately Screen for Transpiration Efficiency in Wheat. The main function of this system is to allow researchers to accurately monitor plant water use over time. This is done by allowing plants to take up water from a water table which is maintained in the bucket below the pot and controlled by a simple float valve mechanism. By controlling the flow of water using this valve, water use can be determined by measuring the amount of water which is removed from the sealed water container. For our system, we've used a 140mm pot, which is the patented ANOVApot. However, pot size can be varied depending on the type of crop being grown. An alternative method of estimating water use is to use the sight glass in the IV line to count the number of water drops over a set period of time. Now this can be done by counting the number of water drops over a 60-second period and multiplying that by 60 to estimate water use per hour. The ANOVApot is ideal for this system as they've been shown to significantly reduce root escape through the bottom of the pot. And for use with this system, reducing root escape is important as root growth into the valve system could potentially interfere with the function of the valve and also impede the ability to measure water use. Now, other pots can be used as a substitute for the ANOVApot, however custom adaptations may be required for the system to function, mainly ensuring that capillary action between the pot and the water table can be maintained, and this will be explained further later. Now, the most important thing to consider when selecting a pot is that there must be a very close fit between the pot and the bucket. Having the smallest possible air gap between the pot and the bucket will reduce water evaporation and increase the accuracy of your data. The first thing you'll need is an elbow piece from standard garden irrigation. Both ends should appear barbed as this, and the other end will be trimmed down to form a flat surface. Next, you will need a disposable 100 microliter pipette tip. Now we're going to cut this at approximately 12mm from the end at a roughly 45-degree angle, so it should look like this. Next, you want to apply a small amount of glue around the outside of the micropipette tip close to the cut end. Be careful not to cover either end of the pipette tip, as this will block the flow of water. So once you've done that, you're going to insert it into the hole of the flat-faced end of the elbow joint. Be careful to face the angled side towards the direction the water will be flowing from. It should fit in snugly, and the glue should form a seal around the end. Once the glue is set, which holds the micropipette tip into the elbow piece, we can insert the other end, which is still barbed, into the length of irrigation piping, which will connect the float valve to the reservoir. Now, if this is too hard to get on, you can sit the length of irrigation in boiling water to make it more malleable before inserting it onto the barb. Next, we can take the elbow piece with the micropipette tip and insert it into the hole which we've drilled in the center of the plastic container. Now it's important here that we ensure that the black hose sits over this hole we've drilled here to ensure that air is still able to enter the valve to ensure the smooth flow of water. So now we can glue this into place using a contact adhesive and allow it to dry for several hours. The float which we use in our valve is made out of styrofoam, and we use a 10mm thick piece cut into a hexagonal shape which is roughly 70mm across. In the center we've punched out a 13mm hole which we've then inserted a piece of black rubber material into, and this forms a good contact with the micropipette tip to stop the flow of water when the valve is full. This is held in place using a bathroom sealant adhesive which is waterproof. To ensure the stability of the pot while resting on top of the valve, and to ensure the valve isn't damaged under the weight of the pot, we use a small square of core flute cut with a small channel on top to accommodate the piping which sits on top of the valve. So once the glue is set on the elbow piece which has been inserted through the base of the plastic container with the micropipette tip in place, we can insert the styrofoam float over the top with the black piece of rubber in the center which will stop the flow of water. Now it's important to note here that the styrofoam float can move freely within the plastic container, meaning that it won't stick to the sides as the water table rises. So once we seal this up, we should be able to see through the side that the pipette tip lines up nicely with that piece of rubber in the center. So that'll stop the flow of water once it's full. So now that we've finished the float, we have to insert it into the bucket. So as you can see, we've drilled a hole through the side which is the same diameter as this tubing. So this will be inserted into the pot and fed through that hole. So as you can see, that float sits nice in the bottom and doesn't move around too much. The next steps involve getting everything ready to insert the pot into the bucket. First, we take the piece of core flute with the channel cut in the top to accommodate the irrigation hose at the top of the valve. Now here you'll see why it's important that we ensure that this hole which was drilled in the top of the valve was covered by the black hose to ensure that when the core flute's inserted, it doesn't seal that hole and prevent air from going through. Next, take a bit of black plastic material which will be used as a root barrier to prevent any roots which do escape the pot from entering the valve. Finally, insert the capillary fabric into the bucket, ensuring that it covers the valve and that both ends touch the base of the bucket where the water table will be maintained. When preparing the pot, we can look inside the ANOVApot and see the painted collar which surrounds the centre hole, which reduces root escape. If you're using a pot other than the ANOVApot, it may be a good idea to insert an internal root barrier as well, to minimise root growth through the pot base. A petri dish can be used as a good substitute to control root escape. To do this, when you're filling your pots, once you have around 2 inches of soil in the pot, place a petri dish with the rim facing down over the centre hole. And this will help to divert roots away from the hole, but still allow water to move through the pot. So the ANOVApots come with a plastic mesh grid covering the centre hole. We remove this by pressing firmly with your thumb and then covering the hole by gluing a small square of the capillary material. This ensures good contact between the soil media and the capillary material supplying water from the reservoir. Now we can insert the pot into the bucket, and you can see that good contact has been made between the capillary fabric at the base of the pot and the capillary fabric over the valve, and this will ensure adequate water flow into the soil. When screwing the lid onto the reservoir, it's important to tighten the lid firmly to prevent any excess evaporation from the jug. However, you also want to unscrew the lid about 1/4 of a turn to allow air into the jug to replace the water as it's used by the pot. If you don't do this, it'll form a vacuum and water will stop flowing. So now that we've completed the float valve and connected the IV line to the tubing which will sit in the reservoir, we can connect the system together and start a water siphon which will allow water to flow through into the valve. So first of all, take the tubing and insert it into your reservoir. Next, take the end of the IV line and suck on this until water begins to flow freely. As you can see here, the water siphon is now started. So the next step will be to connect this to the float valve. And now, as you can see inside, water is beginning to flow freely onto the valve. Once a water table builds up, the float inside will rise, blocking the flow of water on the micropipette tip. So once the water is flowing to the float valve, we can complete the system and insert the pot. As shown before, first we insert the core flute cover and the root barrier to prevent any root growth through the system, before adding the capillary matting and inserting the pot on top. Now water will be able to flow from the water table via the capillary fabric to the base of the pot, where it will be taken up by the soil via capillary action. Thank you for watching this demonstrational video on how to set up the pot in bucket float valve mechanism. Hopefully this has been helpful for anyone looking to use our cost-effective method for measuring water use in plants. For further information on how to construct this system, please refer to our paper titled "A Low-Cost Method to Rapidly and Accurately Screen for Transpiration Efficiency in Wheat," published in the Plant Methods Journal.